Hello, my dear students and the rest of the learners. Welcome to part 13 of the 13-part series of tutorials in C++ computer programming series, in which we are going to learn about files. My name is MemJM, or you can simply call me MLSwap. The data that we create as users and assigned to variables with assignment statement is normally sufficient for some applications. However, with large volumes of data, there is always need for the data to be stored in a storage medium from where it can be retrieved and processed as need arises. Usually, the main memory or internal memory that is used during processing does not store information or data for a long duration of time and is not usually even adequate to accommodate large amounts of data. It is for that reason that files come in handy. These files are stored and retrieved from a storage medium, such as disk. After storing the data in the disk, the computer then helps you to enter, find, change, and delete the data with the use of a program like a program that has been coded in C++. The primary reason for using the disk for storing data is because it is non-volatile and its content is not lost even when you switch off your computer. When working with the disk files, C++ does not have to access much RAM because it reads data from your disk drive and processes that data only parts at a time. Not all of your disk data just reside in RAM for C++ to process it. C++ reads some data, then processes it and reads some more data as the processing continues. If C++ needs some more data a second time, it just reads that data from the disk and places it in memory. Before performing any operation on the data, the file has to be opened first in a certain mode that will enable access to take place. The two ways of accessing the file using, for example, C++ programming language are sequential access and random access. The access mode of a file in which it is opened determines how you are going to read the data, write data into it, change its contents, and even delete data from the file. Some files can be accessed in sequential mode, others in random mode, and others using both the sequential and the random modes. A sequential file has to be accessed in the same order the file was written. If the file was written in sequence, then it is also read in sequence. If the file was written randomly, then it is also good to read it randomly. And therefore, the method of access is usually determined also by the mode that was used in writing the content. In other words, if you write in sequence in a file, then it is also good to read it in sequence. It is difficult and sometimes impossible to insert data in the middle of a sequential file, but for random files, it is possible. Unlike sequential files, therefore, you can access random access files in any order that you want. Random file access sometimes takes more programming, but rewards your effort with some or with a more flexible file access method, which you are calling the random access method. Let's look at sequential files. The three operations that you can perform in a sequential file are: 1 is creating disk file, 2, adding to disk file, and 3 is reading from a disk file. If you are creating the disk file for the first time, you must create the file and then write data into it. In other words, you have to create the file first and then proceed to write the initial data into it. Then as the data grows, you can continue adding new data to the file. We call that appending to the file. That is adding more records to the existing records in the file. When you add to the end of the file, you append to that file. So when we talk about appending in files, we are simply saying that we are adding some additional records to an already set of records in a file, and this addition normally may take place at the end of the existing data. Then you can read the information from the file when need arises. The existing data in the file can also be changed when need arises. The primary approach to changing or removing data from a sequential access file is to create a new one from the old one with updated data. Before you can write or before you can create, write to or read from a disk file, just as I've said, is you need to open the file first. Why? There's no way you can write data to a closed file. There's no way you can read data from a closed file. There's no way you can make modification to existing data in a file if the file is not open or if the file cannot open. And therefore, once you have created the file, you must first open it. Opening is always the first activity that you're supposed to perform even within your code when you are handling or when you want to deal with the files. You must also close the disk file when you finish with it. In other words, once you open the file within your program or using code, you must also ensure that you have code or a set of statements within your program that can be used to close the file. When you open the disk file, you only have to inform C++ of the file name and what you want to do. For example, write to, add to, or read from. In other words, my dear students and the rest of the learners, we are saying that when you are opening a file, you must note what you want to do with the file. So if you wanted to open the file and then write it to it, the statement for opening that file must include some attributes for indicating that you're opening the file in order to write into it. If you want to open the file for the sake of adding some additional information into it, then in your opening statement, you also need to include some attributes that indicates that you are opening the file in a mode that will allow the addition. Similarly, if you want to read content from a file, then as you open the file, you must inform the compiler that you wanted to open that file for the purposes of reading from it. When you close the file, C++ writes any remaining data. The file releases the file from the program and updates the file directory in order to reflect the file's new size. To open a file, you must call the open function. Or to close the file, you call what we call the close function, as we are going to see in this presentation. The format of these two functions calls are as follows. So you write or you begin with the file pointer, then dot. Then the reserved word open. Then we have the opening and the closing parenthesis, what we call a pair of parentheses, inside which you indicate the file name and the access mode. For example, if you want to handle a file called performance within your program, you have to create a file pointer that is going to be used to manipulate the file called performance. And in this case, my file pointer, I'm calling it students file. So students file is the pointer that I will be using to manipulate the file by the name performance. So you have the file pointer, in this case called students file, then dot followed by open. And then you have the opening, parenthesis, and then you list the name or you write out the name for the file that you want to open. And remember, this name should be complete, meaning you must also include that file's extension. If it is a text file, include .txt. If it is a data file, include data file, include .dat, etc. Then we have comma, and then we have IOS, input-output system, then out. Out in this case is the mode in which this file is being opened from. We are going to learn about these modes, and you are going to know what each of them mean. Now, when we talk about closing, we also have to include the file pointer. So if you had opened, for example, a file called performance using a file pointer called students file, then under file pointer, you have to have students file, then dot close. Inside the close, we do not usually include any arguments. For example, students file dot close. This one closes the file. Which file? The file that this pointer is going to be manipulating, or that it has been assigned to, or that it is pointing to. And in this case, if you write students file dot close, the file that is going to be closed, like in this case, will be performance. So file pointer is a special type of pointer that only points to files and not data variables. The file name is a string or a character pointer that points to a string containing a valid file name in your computer. The file name can contain a complete disk and directory path name. You can specify the file in upper or lowercase letters. The file access can be in any therefore of the following modes. The first mode is the app mode. What does app mean? If you add app, it simply means that you are opening the file for the purposes of adding additional data or information. So you are opening the file in append mode. 8 means that you want to seek to the end of file on opening it. In is opening the file for reading, that is in reading mode. Out is opening the file for writing. Binary is opening the file in binary mode. Trunk is discarding content or opening a file to discard its content if that file exists. The no create opens the file or it is used, or it means that if file does not exist, then indicate that opening has failed. The no replace means that if file exists, open fails unless appending or seeking to end of file on opening. So my dear students and the rest of the learners, you must always think of the mode in which you want to open your file. If you want to open the file for writing, then you have to include out. If you want to open it for reading, you have to include in. We are going to see how to do this. So the default access mode for the files is normally text mode. Always open the files immediately before you access them and close them immediately when you are done with them. This protects your files in the case of power failure or in the case of computer breakdown. For example, if you wanted to create a file for storing student details by the name performance.dat in your disk, you would include the following code in your program. So always, whenever you're handling or your program is going to be handling files, the file which contains the header file which contains the functions for manipulating files is fstream. So you should always include fstream as your preprocessor directive. Then we have the main function, under which then we declare a file pointer for writing. Always ensure that you include or you declare a file pointer that you're going to be using in your program, either for writing, for reading, or for any other activity. So in this case, we can have ours being offstream students file. Offstream is a reserved one, and usually we use it when we want to declare a file pointer for writing purposes. And then once we have our file pointer in place, like students file, then we can open our file called performance. Now in this case, if it is .dat, we have to include here .dat. But if it is text, then we include text. Remember, you must always include the full name of the file that you want to open. If it is a text file, we include .txt. If it's a data file, we include .dat. So if our file pointer is students file, then we use that. So students file, we associate it with what? Or we use it to manipulate what? To open performance file, which is a text file, And then we include the input-output stream, and then we ensure that we indicate the mode. And in this case, our mode is for writing. So we are opening it to allow us to write, and therefore we have out included. So this statement creates a file if the file is not existing and opens it to be ready for writing purposes. Now, the remainder of the program or the rest of the statements that we include are for performing other activities in your program that you would like to associate with your file, or any other activity that you would like to perform with your file. The program never has to refer to the file name again. So once you have associated or you have declared a file pointer, and that pointer is pointing to a file, for example, for the performance, we do not need to repeat the name performance again within your program. Whenever you want to perform any activity on the file, you just need to make use of the file's pointer, which, like in this case, will be students file. The program, therefore, uses the file pointer variable to refer to the file. So, like in our case, it's going to make use of students file. Students file being the pointer to the file called performance. You must include the fstream, just as I've said, header file, because it contains the definition for the offstream and ifstream declarations. The students file points to data in the file as you write it. And remember, when I use the word students file, my dear students and the rest of the learners, kindly note that I'm referring to the file called performance.txt in our case. So the students file is the pointer that points to data in the file called performance. Put the declarations in your program where you declare other variables and arrays. So in other words, you declare your pointer that you're going to be using to manipulate your file in the same way or in the same position where we declare other variables. It is advisable to always declare file pointers globally so that you do not need to repeat them at each and every part of your program. So if, for example, you are going to be having several functions in your program, it's good that you include the file pointer outside or before the main function. Before finishing with the program, you should always remember to close the file, and you close the file using the file pointer followed by the close function. So the following close function closes the performance file, students file.close. Why am I saying that it is closing the performance file? It is because already we have associated our file pointer for the performance file being called or is by the name students file. So if you want to close performance file, we just need to make use of the file pointer and then close. So students file.close. If you want, you can put the complete path name in the file's name. In other words, if the file that you are opening or the file that you are closing or the file that you are going to manipulate in your program does not exist within the same folder as your program, it's always good that you include the full path name for that file in your program. However, it's always advisable that every file that we're going to be manipulating using a program is stored together with the source code or is put in the folder in which your source code is placed. So for example, if the performance file is in a subdirectory called file writing in the hand disk, then its name would be coded as follows: students file.open, and then the name of our file is C:, then note the backslash. The backslash are 2, not 1, as is ordinarily done. This will help the compiler be able to know that that is the path, or those are folders and subfolders in which the performance file is kept. So you have to include the full path name, that is hard drive, then in a folder called M&P materials, in a subfolder called C++, then the name of the file in that C++ subfolder or subdirectory is performance. And it's a text file which is being opened to be ready for writing, or it's being opened in writing mode. No matter how you specify the file name when opening the files, close the file with the file pointer. The close function closes the open file no matter which method you used to open the file. So in other words, it doesn't matter the mode you open the file with or in, whether it was for writing, for reading, for appending, or any other, but the close function will always close every file, regardless of the mode that was used. Once you open the file, it is therefore important for you to check if the file opens successfully using some code. For example, hash include fstream, then we have our main function there, and then of course we have declared a file pointer for writing. And then we open our file. And this statement is for opening the file, just as you have seen, and your file is performance. Now, once you have done that, before you start or you commence performing other activities, it's always good to check, first of all, if the file exists. If it exists, then proceed and perform any operation you want to perform with that file. But if it does not exist or it does not open, it's always good for you to generate some message in that context. For example, if not students file, then write out the message, error opening the file. So this message, error opening the file, will be displayed if the file does not exist. Which file? The file that is being manipulated using the file pointer on students file. So if that file is not found, for example, or is not able to be opened, cannot be opened, then that error message will be performed. Otherwise, if the file is in place, then you can proceed and perform any activity that you want them to perform in the file. So you add the rest of the code under the else section. Each file used in a program makes use of its own file pointer. For this reason, you can have a single program, but making use of several files. Now, if your program is making use of several files, you must ensure that you have a separate file pointer for each of the opening file or for each of the open files. And therefore, my dear students and the rest of the learners, we do not use one file pointer to handle several files within the same program. if you are going to make use of two files, even if you're opening one file and copying its content into another file, you must always ensure that you have a file pointer for each of the files. Because once you associate a pointer with a file, or once you open that file using a certain pointer, that file pointer will remain purely to be used for that file. And therefore, if you're having 2 or 3 files or 4 files being handled within the same program, you must have as equal number of file pointers as it is for the number of files that your program is going to manipulate. You can always use a file pointer as you use the cin and cout functions to read and write data to or from a file. So the following function call reads, for example, 3 integer variables from a file pointed to by a file pointer. So we have file pointer, and then, my dear students and the rest of the learners, kindly note, the operators that we use with cin for reading are the same ones that we use for reading using a file pointer. The only difference is that we replace the ones, for example, cin with the name of the file pointer. The same operators we use together with the cout function are the same operators we use, but we replace cout with the name of the file pointer that we are going to use to handle a certain file. For example, if you want to read 3 values, if you want to read 3 values from a file that is being pointed to by a file pointer called file ptr, then this statement will be used to read the 3 variables. Another example, if, for example, you have a file pointer called student details, which of course is pointing or is pointing to a certain file, or is being used to manipulate the content of a certain file, then in that case, we can read integers. We can read 3 integers from that file using the statement students file details, which is the pointer, and then we have our usual operators, and then we have score 1, score 2, and score 3, meaning that score 3, score 2, and score 1 are already integer variables that have been declared, or that are already part of the file. You can then write data to the file, for example, as follows. So you can see the difference between the reading and the writing statement. The only difference, I repeat, my dear students and the rest of the learners, is that instead of cout and cin functions, we make use of the file pointer. So we just replace. So the name of the file pointer remains, whether you are using it for reading or whether you're using it for writing. The name of the file pointer remains. So we don't have different file pointers for reading and for writing if we are making use of the same file. And therefore, what we only need to change are the operators. The operators, as you can see. For example, students file. So this statement means read score 3 or write score 3, score 2, and score 1 into the file that is associated or that is pointed to by the file pointer called students file. Each line in a file is called a record. Remember, in a file you keep records. So every line in a file is called a record. By putting a new line character at the end of the file records, you make the input of those records easier. It's always good when you are writing in a file, you always terminate each of them, each of the contents in the file, using a new line character. The following is an example of a program implementing creation of a file used for storing the scores attained by 5 students in 5 subjects, inclusive of the total attained by each student. It also implements functions an array of structs. In other words, my dear students and the rest of the learners, the program that we are about to see is the same program that we coded in the previous presentations under the structure, and we used it under the arrays topic, and also the same knowledge for functions apply. I would therefore kindly request, my dear students and the rest of the learners, that if you forgot how to manipulate structs or structures, the pointers, as well as functions and also the arrays, you go back to the previous series of presentations, one on the structure, the other one on pointers, the other one on functions, and the other one on arrays, so that you can be able then to connect. Because the purpose of this presentation, my dear students and the rest of the learners, is to show you how you can keep the data that we have been manipulating using files that we have learned or programs that we have learned in this series from part 1 to part 12 in a file, and how you can be able to access that data from the file into the program and be able to use it in the same way we have been using data in the previous tutorials in this series. So in this program, we have the file name. The file name is file writing. Remember, you can give it your name, the name that you want, but always remember that even naming files requires the names to be meaningful. Then it writes 5 students' records into a file. We have pre-processed directive outstream. Then this time, you can see, because now we are coding a program to manipulate the files, then we are now including a new pre-processed directive that we have not included the previous presentations, which we are calling the fstream. Note, for some versions, you need to include fstream.h, but for Visual Studio 2010 and other later versions of C++, you do not need to include .h. So in the case you write fstream, you code fstream without .h, and then it is generated, it is displayed as an error. It's always good you include .h, meaning it's a header file. We also have another header file or process directive that we call iomanip. This one is mostly one which contains functions that can be used to format your data on the screen or even on the file to format the output together with the input also. Then we have using namespace, standard. Then, because my file is going to store data that has been manipulated using a structure, then I have a definition of a structure by the name student scores. And then this structure has the following members. It has student name, It has a member called com score, CA score, SIS score. We have math score, OOP score, and the sum. Now these are of type integer. And then that's the end of our definition for the structure. Or you can call it, sometimes people are tempted to call it declaration, but you don't declare. This is not declaration, it's definition. You declare at a point when you assign an instance or a variable or an object to be used to manipulate this structure. So for now, there is no memory which has been reserved for it because we have not yet indicated any object at this point. Then I have a global variable called overall sum for the purposes of computing sum from a number of functions. Then my program is going to make use of some functions. So because these function definitions have been done after the main, I have to prototype them. So the first one is get data. This one is the one which is supposed to get data, which is supposed to be entered into the structure called student scores. So this function is receiving one parameter, and the parameter is an array of students, which is of type struct. So type struct student scores. That means it's a structure. The second one is the function for computing total. It's called compute total. It's also receiving one parameter which is of type student scores structure, and it's not returning any value. Another function is write data. It does not return any value, but it receives a parameter which is of type struct student scores. Then we go to the main function. Here we declare an array of instances for our structure. So this is a declaration for an array of struct. So the object or the instance in this case is students. Student is of type student scores, and it is an array of struct. Then we move on to the call statement for the first function. The first function is called get data. What is being passed into it? What is being passed into it is the array of struct. Who is the name of the array of struct, and that is students. So we are passing students. Now, once this statement is invoked, then the compiler goes to the prototype, this one, and then it will look for that function after the main. And here is the function. So what is this function doing? It is receiving the parameter, and then it is then prompting the user to enter members into the structure. And I will not explain much about this because already I explained the same under the structure topic. So you can go through that structure or that topic called structure and go through it so that you remind yourself about what this section is doing. Then we have return there. So by the end of this brace here, already our structure contains data. Already our structure contains data. Then once the return statement is executed, the compiler goes and it continues with where it left. So the next function to be executed is compute total. The compute total function is being invoked by passing the struct member or the array of struct by the name students. So once this statement is executed, the compiler will go the prototype for compute total, then know it exists, and then after main, the program will run, or the compiler will go to the function called compute total. So compute total is going to perform the computation, the values in our structure. This is also well explained under the structures. It's well explained under the structure topic. So I still advise that you go through that presentation to remind yourself about how this function is working. Then from there, the next function to be invoked, or the compiler will go to the main program and then execute the next statement, which is write data. The function is called write data. So our interest in this presentation is on this function. So this function is going to receive an array of struct called students. So once that statement is invoked, the compiler will come here, find the format of that function, that's a prototype, and then go after main and look for that function. Where is our function? So the compiler is looking for it. Here it is. So this function writes the data entered through the structure inclusive of sum into the file called performance. So the header is the same. This is the header for our function. It is receiving the member, or it is receiving the parameter of type struct student scores by the name students, and it's an array. So the content there are going to be manipulated here. So one local variable that is being declared now is student num. Then we declare a file pointer for writing. Now, we have not yet associated this pointer with any file. So what you're going to do next is to open the file. So we open the file using the pointer. So students file.open. Open what? So we are creating a file called performance.txt, and it's going to be used to write the data from the struct into it. So that's what this statement means. We are opening a file. That means we are creating and opening it by the name performance, and it's a text file, and we are going to write into it. So it is opened in write mode. So from there, we check, is the file ready for writing into? If not, we display the error message. Else, we continue. So what are we supposed to do then? So the first thing we need to do is to write this statement into a file. So the compiler will write the statement, or the ones the students resource from the structure are as follows. So this one will be written in the file. Which file? Performance, the one which is being pointed to by the student's file pointer. And then it's going to do the following. It's going to create a space of 15 characters, then write the heading name, space 15 characters. Next heading is com score, the space, C score, space, all the way to total. So these ones will be the headings in the file. These will be headings in the file. And then once that is done, we then commence writing our data in the file using the for loop. Remember, our records are several. In fact, our students file, or our structure is an array for 5 records. And therefore, we expect this 4 to do that work of writing. So what is it going to do? It is picking the first is having a space, and then it writes out. It writes out the student's 0 dot student name. So the name, the content of the member student name for the first student is going to be written out. Then students 0 com score. Then student 0 CS score. Student 0 SIS score. CA 0 math score. Students 0 OP score. Students 0 SAM. So that data will be for the first record whose index is 0 or subscript 0. From there, it is going to drop one line. And then once this brace is encountered, this first brace, it will increment counter or student num. Remember, initially student num was 0, so it will be increment 1. So student num will be incremented 1. That is 0 plus 1. Then check, is 1 less than 5? Yes. So it will now proceed again writing the content from the student structure, or from the structure. So it is going to write out students 1, student name. The content there will be in the file. Then students 1 com score. Student 1 dot CAS score. Student 1 dot SIS score, all the way. And once it writes out some, it will drop one line in the file, write out one blank line. And then from there, it will increment again the counter. So the content of the structure called the students that we have looked at, the student details, that structure, the content of that structure, this structure here, let me show you. The content of this structure that we have already looked into, this one here. So all the content of student course structure for the 5 students will be written out in the file. It will be written out in the file using this function here. So once the writing is done, we move on to closing the file. So once the 5 records have been written, that's up to student 4 dot name, student name dot student's course etc. Then the file is going to be closed using this statement. So it will close the file that we have been writing into. Once that is done, the message will be displayed on the screen. Congratulations, the file called performance has been created successfully. And then once that is done, the control will be taken back to the main program. And what is under the main program? the main function. So the next statement will be to take back control to the operating system and end the program. Now, what do we expect to see? We expect to see, as you have seen, that when we look in our, or when we execute this program, we expect it to create for us a file called performance and write out this information into it. And then once that is done, the program will have succeeded writing the content in the file. So let us now code this program in C++, editor, we compile and execute it so that we see how it behaves and the results that we are going to get. So let's see if after we code this program and we run it or we execute it, it is going to create for us a file called performance, as we have seen. And in that file, we have the scores attained by 5 students. So we expect to see these headings there. We expect to see these headings in that file. We need to see that message, that heading. We also need to see those headings and the content for each of the 5 records. So we have to enter the first function here is to enter the information. So once we execute this program, we expect it to prompt us to enter the information. Student first name, communication score, computer application score, software installation score, mathematics score, and OOP score. And then we expect it to compute the total for the values that we have entered using this function. And then we have all those data, all that data being written out using this function into the file called performance. And it will be a text file. So let's proceed. Let's start our C++ program. So we start our C++ program, and then we start new file. There we go. So we create a new project. What name are we going to give it? Let's remind ourselves about the name that I'm using in my program. The name for the file, or the name for the function, or for the project, the name for the project that we want to create is file writing, because it's going to deal with writing into a file. So we call it file writing. I'll click OK. Then I'll proceed for Visual Studio C++ 2010. Then I'll create a source file here. This code C++ file, and the name is file writing. I'll click Add. So because my program is already ready, I'm just going to copy my program. I'm just going to copy my program. Where is my program? This is the program that I've already displayed on the screen. So this is the program. I don't also like you to copy the program that I've displayed on the screen and copy it into your editor and then paste it into your C++ program, then save it, compile it, run it. So let me copy my program. It's always good and it's always advisable that you write a program in your exercise book. You write the program in your exercise book, try run it in your exercise book, check if it is doing what you would like it to do, check in errors that you can be able to rectify your work while it is on paper. That's called dry running. Also think about the output and how the program behaves. Then from there, code it in an editor like Microsoft Word, or write it directly into your C++ editor, like what I've done. So once I've done this, you save your program. Then you compile it. So for Visual Studio 2010, we click on Build, and then build solution. Let's see if our program has any errors. If it has no errors, it will inform us. Good. So our compilation has been successful, meaning that our program has no syntax errors. If there are any semantic or logical errors, we are going to see when we execute this program. So let's execute the program. So click on debug and then start without debugging. For your case, if you are using another version of C++ program that is not Visual Studio 2010, instead of clicking on debug, it may be compile then execute or run. So already our program is executing the first function, which is for entering data, the structure. So let's enter the data. So I'll enter my data as follows. Second student, I'll call my second student Agnes. Then I'll enter some scores for Agnes. The next student whose index is 2, that's that student. I'll call that student Otieno. And then I'll enter some values into that index. Then from there, I got the fourth student or the fourth record whose index is 3. So the name of this student is, I can recall her, Rose, then enter some scores for Rose as follows. Then the fifth record, remember, our structure is an array of structs, meaning it is having 5 records, and each of these records has several elements or fields. So this other student or this student is done, and then I enter some values for that student. Now, what will happen once I press enter? Let's see where we are. Now, there's part of the function that is being executed for now, my dear students and the rest of the learners, is the get data function. And you can see it is going to accept students' records, 5 students' records, that's from student number 0 to student number 4. And this is what we have done. So once we press enter, because that's the last record, or the last set of data to enter, you can see the message we are getting. We are getting the message, congratulations, the file called performance has been created successfully. Press any key to continue. So that means already the data has been accepted, computation has been done, and the data has been written into a file. So a file called performance has been created, and the information that we are writing into it from the program has been stored there. Let us confirm if our file has been created. So where is our file? Our program is in a folder called C++. You can see, we can see this is this program. This program is here. So this is the folder. You can see the time is just now. So I open this folder. It's called file writing, and open that folder. If you look carefully, the time now in my computer at the bottom of the screen, you can see it is 11:13 p.m. If you check here, this file has been created at 11:12 p.m. That's just now. So this is the file which has been created. The program we are executing is this one. If I double click here, you can see this is the program. So this program is strung together with the file which it has created. So this program has created this file. So let's open this file and see if it has the data that we have entered. So right click on it and open. Good. You can see our file is called performance. And these are the students that we have just entered just now. And this is the information. And you can see even the total has been computed and added into our file. So our program has successfully created a file called performance. And therefore, it has also been closed. So that's it. Our program has performed the task excellently. And you can see the file is called performance. It's a text file, and our records have been added into it with the headings, just as I have already stated. You can always also add data to an existing file or create a new file by opening it in append access mode. Therefore, the files you open for append access using input-output stream append, that is APP, do not have to exist. In other words, you may want to append files or records, you may want to append records in a file that does not exist. The append mode, if you open a file in append mode, it will also create that file if it does not exist. And if it exists, it will just open it in a mode that will be ready for addition of records. If the file exists, it's good to ensure that it is accessible in the same folder as the program source. You can thus always copy the file from wherever it is and paste it in the current folder. C++ appends data to the end of the file when you write the data. If the file does not exist, C++ creates the file as is done when you open a file for write access. Basically, you only have to change the open function access mode to turn a file creation program into a file appending mode. For example, students file.open performance.txt, then instead of out, you add the mode append, APP at the end. So this statement opens the file called performance for addition of records. And please note, in this case, it's always good to ensure that you copy this file and have it in the same folder as the folder in which the program that is manipulating it is. Otherwise, you'll be required to write the full path for it. Therefore, the following is an example of a program that adds any number of records to an existing file by the name performance just created earlier. Or in other words, this program, the following program is a program that is expected to add some files into our file to add some records, I repeat, the following program is an example of a program that can be used to add some additional records into the file that we have already created called performance. So my name or the name of my file, the source file, is file appending. And then this program is meant to add records into an existing file called performance. We have the outstream there, we have the airstream, the almanib, the namespace. Then we have our structure, is the same structure that we have used. And then I have a global variable for counting the number of records. Then the function prototypes are there. I have the function prototype for getting the data. I have for computing the total and also for appending records. So these functions or prototypes are almost similar to the other one that we have already looked at, but now the one which was reading write data is the one which I've changed so that it now reads open or append records. Then we have our main function there. Of course, the core statements are the same. You declare the array of struct. Then we have the function for allowing us to enter additional information. We have the function for computing the total. Then we have the function for appending records, which is of key importance to us. So once this statement this call is invoked, the program will go to the prototype for get data. Here it is, and then proceed after main and go to the function for getting data. Now, if you look at this function, I have this statement here. How many records do you want to add to the file? Because the file is already existing. Then maybe somebody enters 2. Then the next message, enter the student's information. So this message will be displayed on the screen. And then you enter the number specified from student's num to numRex. So initialize student num to 0. Check if the value of student num is less than num records. So if somebody has said number of records to be entered are 2, here it will be is 0 less than 2? Yes. If yes, request or write the student number, the index, that is index 0. Then prompt for student's first name, get that first name and keep it in there, store it in the member of struct called student name. Prompt for communication score, read the value and store it there. Continue reading each of the values. Continue reading each of the values until this brace, the last brace here is an countant. Then increment the value of counter, student num, with 1. So 0 plus 1 is 1. Then check the condition. Is 1 less than 2? That means when the user was probed for the number of records, he or she entered 2. So is 1 less than 2? Yes. If yes, read the student's 1.student name and continue that way, reading each value and storing it in the respective member. Then increment the counter with 1. So 1 plus 1 is 2. Is 2 less than 2? No. So come out of that loop and return the control back to the operating or back to the main function, back to the calling function. So after we have read our data, then the next function to be executed is this statement here. This statement will be invoked. The function called compute will be invoked. And what will be passed into it is the data we have already entered in our structure called student scores. So the data we have already entered is being passed to the function called compute total. So the compute total, the prototype is here. The compiler will look for the compute total function. So it will go to the compute total function and perform this activity here. So what is it doing? It's going to add the scores that have been entered for each of the students from student num 0 to student num 1. Why? If the user said that he or she wants to add 2 records, then it means it is index 0 and index 1. So the data for that or those values will be added, and the results will be stored in the respective member. And the students 0 num students 0.sum, the score for the first student will be stored there. Then the students 1.sum for the second one will be stored there. Once that is done and this last brace is executed, this one, the control will be taken back to the coding function, which is main. And then the next function to be executed or the next call statement to be invoked is this one. So the function called append records will be invoked and it will receive the data which has been entered through the struct called student scores, but under the object by the name students. So the data there will be passed over to this prototype or this function called append records, whose definition will be found after main here. So what is this one going to do? Now, this is how this function will work. This is the function which is going to do the appending. So it will receive the parameter called students, who is an array. And in this case, we know the amount of data that function is receiving is for 2 students. So the function is declaring a file pointer for appending called offstream student's file. And then we are now opening the file. We are opening the file called the performance, ready for appending. So the file which you have already created called the performance is going to be opened using this statement. So this statement opens the file called performance, ready for adding records. Then it's always good to check if the file is open or if it can open. Is it open? Is it there? If it's not there, display the message, error opening the file, or if the file cannot be opened, display this message. Otherwise, if it exists, do the following. So commence. Commence doing what? Initialize student num which is counted to 0. Check if 0 is less than num records. Num records is the number of records that you enter. So if you enter 2 records, it is num records now contain 2. So is 0 less than 2? Yes. So do what? Write the following into the file called performance. Create a space of 15 characters. Then write student 0 dot student name. So write the name of the student whose index for now is 0. Then have space, continue, write for students 0 com score, student 0 CS score, and continue that way until you encounter this brace. Then increment the value of counter with 1. So 0 plus 1, that is this last part here, student num, increment. So increment the value of student num with 1. So 0 plus 1 is 1. Then check the condition. Is student num less than num rex? Is 1 less than 2? Yes. Then continue. Write out into the file. Write out the file called performance the following information for the student number 2. That is students whose index is 1. So students 1 dot student name. Write what is there in the file. Write what is in students 1 dot com score to the file. Continue that way until you are done. Once you encounter this brace, increment the value of counter with 1. So 1 plus 1 is 2. Is 2 less than 2? No. So that means this loop will be exited. And then the file will be closed. So this will close the file called performance. And then the message, congratulations, the file performance has been updated successfully, will be displayed on the screen. And then the control will be taken back to the main. So let's go back to the main function. Once we go back to the main function, the next statement then to be invoked will be return control back to the operating system and end the program. Now, having said this and having explained this, my dear students and the rest of the learners, let's proceed then and execute our program. Copy this program as it is. We copy this program as it is, and then we paste it in C++ editor. We compile it, we execute it, and see if it will add additional records to our file. So this is what we are going to do. So let me open my C++ program. I'll close the file which is already open. That way, I'll close the workspace and close the solution, and then start a new project. What is the name of our project? What's the name of our file? So let me go back to our program and see the name of our file that we are creating now, that we are coding. So it is file appending. So I'll call my project file appending. So file new project, this Win32 console application, and then I type the name file appending. File appending. Then I'll click OK. Then from there, I will proceed with the process as usual. Then right click here, new item. I am writing source code in C++ file. The name of the file is file appending. File appending. Then I'll click add. So there we go. The next thing I'll do is let me copy my program, which I've already explained. This is my program, which I also expect that you have also copied in your exercise books or in your editor, like Microsoft Word. So just copy that program. I'll just copy mine, which I've already explained. And remember, I've said it's always advisable you write your program on a piece of paper, dry run it there, or write it in an edit like word processor, like in my case, what I've done. And then copy that program, paste it on your or in your editor. So I pasted it in C++. You can see this file appending. So I'll save it. Then let me compile it. Remember the purpose of compiling is to convert your source code into object code. In case it has any errors, then the conversion cannot take place. Good. My conversion has been successful, meaning my program does not have any syntax errors. If there are any logical errors or semantic errors, we are going to see them during execution. So the next step I'm going to do is to execute my program. There we go. Now look here. It is asking how many records do you want it to add to the file? Meaning, already the program is executing the first function for getting data, which is this one. This one. So how many records? I'll type 2. I want to add 2. Then what will I do? My dear students and the rest of the learners, kindly follow and see what will happen. If I press 2, it will then start asking me for the information. So first name, this time I'll add somebody called Ghana, and the scores are as follows. The second one, remember there are 2, I've said 2, so it is index subscript 0 to subscript 1. So the other one, I'll call her or I'll call him Salat. And then the scores will be as follows. You can see we are getting the message, congratulations. The file called performance has been updated successfully. Now, the question that I want you to ask yourself, my dear student and the rest of the learners, is this. Has this information been added into our file called performance? Or the file called performance has been created afresh? Remember, I have already said, if you are opening a file in append mode, like in our case, I have said if the file does not exist, a new file will be created. So let us open this folder containing file appending program and see if the student file which we had created before, the file called performance, has been added records or it is a new one which has been created. So let's proceed and see. So let me go to this folder here. There we go. This is the folder that has been created just now. It's called file appending because we have created a program. We have executed a program called file appending as a new project. So that project has been kept in this folder. So if you open this folder called file appending, you can see this program. In fact, this is the program that we execute. Now, the question is, do we have a file called performance? Yes, here we have a file. But is the content here and additional to what we had? Let's open and see. If we open this file and we click open, let's see what is inside. You can see that we have a new file. The new file is called the performance. It has 2 students. The others are not here. These others are not here. Why? Because our file that we were adding our records to, we had not copied it, into this folder called file appending. So a new file has been created. Note, this was the previous file. This was the previous file. So our expectation was that these two students we are adding, Juliana and Salat, will be added here. So what are we supposed to do then? When we have seen that the append mode creates a file if it's not there and inserts new files into it. So what we need to do is I'll close this, I'll close this, I'll close this. I will not save the file. I'll click don't save. And then what I'm going to do is I'm going to delete this file so that you see. I will go to the folder, the file which I had created earlier. That is file writing. I will open it. This was our previous file that we have already, or we created, or we have created in the previous program. So what I'm going to do is I'll copy this file, copy it. And then after copying it, I'll paste it in my current folder, which contains my source code for adding files. So I'll paste it here. So this is my file now. Now, once this file is here, I'll close these others. Once this file is here, I will then run again. I'll run again my program. So I'll just execute my program again, this program. And then we see whether to add the students there. We have added a student called Juliana, and we are going to add one called Salat. So I will execute my program again, run without debugging or start without debugging. That means I'm just executing it. And then I'll still say true. Then I'll enter my students. The first one who I want to add is Juliana. Then I'll enter scores. Then you enter new scores for Juliana. Then the second student is called Salat. Then let me enter marks or scores for Salat. Hey, one has really been exited. It's okay, no problem. We are learning. So once I press enter, what are we being told? Congratulations. The file called performance has been updated successfully. Press indicate continue. So let me press a keep continue. Let's now confirm if our file has been appended. So this is our file, our initial file. We can see the time now is 11:37, as you can see at the bottom here. And this file has been created just now, 11:07, meaning it has been modified. Let's open it and see whether it has additional 2 records. Great. You can now see that we have our previous records and 2 records have now been added, have been appended into it. And my dear students and the rest of the learners, that's how we append records into an existing file. And that's how we code our program. So the part which has done the appending or the functions that have been used are the functions that have already executed. And this part, this function for appending is the one which has done the appending. What else can we be able to do using files other than appending? So once data is in a file, of course, it cannot be valuable if it cannot be accessed and read. Therefore, you must open the file first so that you can proceed and read the data. If you try to open a file which does not exist or contains no data, an error message can be generated. My dear students and the rest of the learners, as you have noticed, we have opened our file called performance manually, just for the purpose of confirming whether our file has been created and also whether our records have been added. But you can also write a program that can be able to access that file and display the content on the screen. That's what I'm trying to say. So every file becomes important and valid if you can be able to read data from it using a program. So how can we be able to read data from a file through a program? That's exactly what we want to do. So if you try to open a file which does not exist or it contains no data, an error message should be generated. Therefore, a file is first opened in read access mode, after which reading can proceed. The open function returns 0 if the file does not exist when you open it for read access. In addition, if you try to read a file after all its data has already been read, the compiler should also return a value of 0. It is therefore always important to find the end of the file, and this is done using the end of file condition and checking for value 0. The syntax for opening the file for reading is as follows. Now you can see we change the reserved word or keyword if stream. When we were opening a file to write into it and append data, we were using of stream. Now, because we want to declare a pointer to be used especially for reading of the content of the file, then our file pointer will be preceded by the word if stream, if stream from the file into the program. If stream followed by the name of the file pointer. For example, file pointer dot open file name, then input output stream, and we are opening it in reading mode. So this is the syntax. This is the syntax. First, you declare a pointer. Second, you open the file in a mode that is appropriate for reading, which is in. For example, if you want to open our file that we have created using our pointer which you have been using, or a new pointer called student pointer, then we can have it as if stream student pointer. That's the name of my file pointer. Then from there, which file will I be manipulating using this pointer called student pointer? So I have to open now the file which I want to open or associate with my pointer. So in this case, is student pointer dot open. Open a file with a certain name. Input output in, that is in reading mode. Now, why am I using the word now, file name here, inside the parentheses instead of writing the specific name? It is so that I give the user provision or room to be able to type any name of any file that he or she wants to open. That's why you can see in this case, file name is a variable. It has been declared as a variable. So it is going to be or an array of characters so that they can be used to be holding any name that the user will enter for me. That's the difference between this statement and the ones which we have looked at in this presentation earlier. So there are several ways to read data. You can read character data, one character at a time or one string at a time. So the following is an example of a program that prompts the user for a file name whose contents he or she would like to be displayed on the screen. Then, if the file is not found, it displays an error message. Otherwise, it displays the content of the file on the screen and informs the user about successful reading process. So my name or the name of my file or my program is file reading. It checks for existence for a file requested, pins its contents, and displays it on the screen. I have my preprocess and directive, our stream, then fstream for the purpose of handling the file. Then using namespace, then I declare a file pointer for reading. The file pointer for reading in my case is ifstream. The name of the file pointer is student's pointer. Then main program. Then I'm declaring an array of car variable called file name. We used to hold any name that the user will enter. And then in car for the purposes of holding characters from the file as they get read. Then I'm asking the user, what is the name of the file that we want to see? The user will type a certain name. For example, performance. That name will be read. The characters entered will be read and stored in the memory location called file name, whose maximum number of characters should not exceed 20. Then from there, whatever that the user has entered, if the user has entered the file name being performance, then the file that has been entered will be opened in the mode of reading by the statement like students pointer dot open in bracket. Whatever is stored in the memory location called file name. So if the user has entered the name of the file being performance, it will be the one which will be displayed. It is the one which will be opened in reading mode. Then from there, check. Is the file which has been entered by the user existing? If not, display the message. The file does not exist, or you have not added its extension. Retry. Then exit the program. Otherwise, if the file is existing, read the content and display it on the screen. So how will reading take place? While students pointer, now get is a function for reading from a file, get. So read every character inside the file and bring it into the program, or write each of the characters on the screen. Write each of the characters on the screen. So continue until there is no more character remaining in the file. So continue reading for as long as there is content, for as long as there are characters. But once the characters are done, once an empty space is encountered, then end the while and close the file. Close the file. So that's what this program will do. And then it will display the message. Congratulations. The file code, whatever you are decoded, the file called the performance has been read from successfully. So the control will be taken back to the operating system and the program ends. Now let's see. If we copy this code and we write it in our C++ program and we execute it, is it really going to open for us any of the files? And if our files are not existing, is it going to display that the file is not found? Let's see. So what we are going to do is we are going to go back to our C++ program. I'll close this program. I'll close the program that I've been working on and start a new project. New project. This Win32 console application. What is the name of my project? The name of my program, the one which I've already demonstrated, is file reading. So I'll call my project file reading. Remember, you're free. Give your files any other name or your project any other name, but ensure that the name is meaningful. So I'll right click here, click add new item. I'm coding C++ source code. The name of my source file is file reading, or the name of my program is file reading. Let me copy my program as usual, just as it is. This is my program. Let me copy this program, the one which I've already explained, just as it is, and paste it on my editor. So there we go. Let me paste it here. So this is my program for file reading. This is my program for file reading. So if I compile this program, it should be able to perform the activity that I wanted to perform. So as usual, we are going to save it. Then click on build solution. So we compile our program. You can see that our compilation has been successful. So let's execute our program and see what it will do. What is the name of the file that we want to see? Let me type a name. I want to see a file called performance.txt. Press enter. We are getting the message, this file does not exist, or you have not added its extension. Let's type another one. Let's run that program again. What name of the file do you want to see? Let me type results and press enter. We can see that the file is not existing. What does this mean? These error messages are simply telling us that we are trying to open a file which is not already in the folder where it is being sorted from. So what are we going to do? Let's go to our folder. Our folder is the folder that has been created is file reading. This is our folder. Let me open this folder. You can see this folder has no file. So there's nothing which was being read. So what we are going to do is let me copy some files. I will copy some files. So there was a file here and a file appending. We have this file. So let me copy it. I'll copy this file, and then I will add it into the folder called file reading here. So let me paste my file there. Let me look for another file. And there's this other file here. I want to copy this file. Copy this other file here called results, and I'll paste it here. Let me paste it here. So these are two files that I've added in the folder called file reading. Let me run my program again. Our program is file reading. That's the program. It's always already displayed on our screen. So let us run this program again and we see what will happen. So I'll click on, let me compile it afresh, build solution. We can also rebuild the solution. You can see it has been successful. Let me then run this program again, start without debugging. Let's try again. What is the name of the file you want to see? I want to see the file called performance. I'll type .txt in full and press enter. I'm being told that it does not exist. So what is it supposed to be called? Is it performance or performances? I'll run my program again. Start without debugging. Then let me type another name, performances.txt, and press enter. It is still not existing. Let's see, where is our file? Where is our file? Do we have it? Do we have a file? Do we have file and a file reading? No. So I have to copy them again. Remove them from here. Then I have to add them here inside this folder where my program is. This is my program. These are my files. So let me run my program again. So build solution. Let's rebuild the solution. Rebuild is successful. So let's execute it. Start without debugging. Let me now enter the name performance, the name of the file performance.txt. See, press enter. you can see that now the content for a file has been read and displayed on the screen, as you can see. As you can see, the file contains all our records. This is the updated file. Congratulations, the file called performance text has been read successfully. Let's read another file. Let's read another file using the same program. What is the name of the file we want to see? Let me write results.txt. Press enter. You can see this is another file. And in fact, this file even contains very many students. Congratulations, the file called results has been read from successfully. And you can see even the totals are there. So that's how you read any file. That's how you read any file and display the content on the screen. You can see that the program for reading the contents of a file is very simple. So my dear students and the rest of the learners, just copy this program as it is, understand how it works, and then be able to execute any program and open any file of your choice, just as you have seen. Other than reading data from a file and displaying it directly to the screen, you can also read data from a file into the program. For example, into a struct or a class. That is, input data into the program from a file instead of entering data from the keyboard, from where you can then perform further processing operations on the data. The following program is therefore an example of a program that you can use for reading data or a number of records as specified by the user from a file into a program's structure, and then from that structure, be able to display that data on the screen. In other words, you can use your file as the source of your input to the program. Instead of prompting the user to enter data to the program, you can read data that is found in a file in the program, as we are going to see. So how do we do it? So this is an example. The name of my file is file read struct display. It reads records from a file into a structure, then displays records from the structure to the screen. Here we have our preprocessor directives as usual. Then we have our structure. We want now to read our data into this structure from a file and display it on the screen. So that's a structure that we have already used. And then I have the global variable there. I have the prototypes, the function for getting data and for displaying the data. Then we go to the main function. Here, I am declaring array of objects or array of struct. Array of struct. We call it array of instances initialized to 0. In other words, in this case, I am setting memory location aside to be used to hold 20 records of students or details of 20 students, 20 objects. So I'm declaring an array of struct. An array of struct called student scores and initializing all the members to 0, making it ready so that in case a student wants to search for students who are not in the struct, then we are going to have zeros. Then I'm provoking the first function, invoking the first function, which is get data. So once this statement is invoked, the object, the struct of array, the struct of array, or the array instance, the array object called the students will be passed to the function called get data. So that object will be passed containing all the data that it holds to get data. So let's go to get data function. There is the prototype. Then we go to the definition of the function. So this is the function get data. It is receiving a parameter, which is an array of struct called students. It has a local variable. Then it is declaring a file pointer for writing to the screen. So if stream student file. And then it is opening the file for the performance. Look here. This is a statement This is a statement for opening a file called performance for reading. For reading. So the first work to be done is to confirm, does the file exist? If the file called performance exists or does not exist, if it does not exist, display the error message. Otherwise, end the exit if it's not there. Otherwise, if it exists, do the following. Ask the user, how many records does he or she wants to enter from the file to the structure? Then read that value. From there, create a new file or open the file for reading or for writing. Open the file for writing. Remember, we are supposed to read. We are supposed to read data from a structure. So you can read from structure to the screen, and you can read from a file to the structure. So when you read from the file, you write to the structure. And you can read from the structure and write on the screen. So are we opening the file for writing or for reading? Are we opening the file for writing or for reading? If there's any problem with the comments, kindly identify that problem under comments. Because sometimes you may have wrong comments, but the program is doing the right thing. So it's good to know the difference. So here we have this part where we are manipulating the members of the file. So if you have said you want to read 2, if you want to read the 2 or you want to write the 2, then we have to have numRex. numRex is a number of records. So we continue with that. The explanation is same as I have explained before. Then proceed, increment the counter, do the next activity, for writing. And then once you are done with that, kind of note, instead of reading or writing using C in or C out, we are using students file. So we are reading a value and writing it out. Once we are done, we close the students file. What have we done? Have we read from the structure and written to the file, or we are reading from the file and writing to the structure? Let's see. So once that is done, once that function is done and it's completed, then the compiler or the control will be taken back to the caller, the main function, and execute the next statement or the next call, which is display the data. So this function is being invoked and the array of struct is being passed into it. So the compiler will go to that function, yes, the function, and then go to the definition of that function, which is for displaying the records. So how is the display? So remember, the data that we have read from the file and written in the structure is now being read from the structure, the screen. So on the screen, this heading will be written on the screen, and then the compiler will now pick the content or will now write these headings on the screen and then start reading the data for the number of records that the user has requested for. So it will write out this. It will pick what is students 0, the student name, displayed on the screen, the spaces or formatting as follows. And once the first record is done, the count will be incremented with 1, then read the next record. And then once this statement is, this is an accountant, the processing will complete. In other words, this function is writing out the content of the structure to the screen and formatting it, as you can see, using setW function, which is defined under the Almanip file. So, my dear students and the rest of the learners, what is important for you to note is the get data function. So this function is reading. This function is reading the content of a file and writing it into the structure members. It is reading from the file and writing that data into the structure members. And then this other function. Now, once the reading is done, the file is closed. Or is taken back the main program, which then invokes the function for displaying the data. And what this function is doing is reading from the structure and displaying on the screen. And once that function is completed, control be taken back the operator to the main function, and control be taken back to the operating system, and the program will end. So let's see if we execute this program, how it will work. So let's now code this program in C++ and data, compile and execute it so that we can see how it is going to behave. Remember, the name of our program, the name of this program is file_read_distract display. File_read_distract display. So let me close this program as usual and begin a new project. Let me begin a new project. The name of the project is file. We have seen it is file what? Let's remind ourselves. It is file read distract display. File read distract display. File read distract display, meaning we are reading from a file text structure and then displaying it. File read distract, file read distract display. Okay, so we continue. Remember, if you're using other versions of C++, you don't need to follow this long route. Like if you're using Falcon, just start C++ directly and the code. So the name of my program is file start read display. File start read display. So I'll copy my program. Here it is. Let me copy this program that I've already explained. Let me copy that program and paste it on my C++ editor. There we go. Then save it. Let's compile it. Good. You can see that our compilation has been successful. So we can run it. Execute it. It's already giving us an error message. Error opening the file. So which file are we opening? Remember, we have already told it that the name of the file is performance. So it means we need to have this folder, this file into our folder. So what we are going to do is we are going to copy our folder or our file called performance, then go to the folder which we have just created, the folder which has begun by the program for the project is file read distract display. So I'll open it, then open this subfolder and paste my file there. So this is my file. This is my file. If I open this file, you will see what is inside. So let's close that file for now and run our program again. Remember, our file is called performances. So let's start without debugging, or let's execute again. You can see still the file is not called performances. Where did we have the file called performances? Which folder? So let's see where we had the file called performances. And for reading, we didn't have performances. And file appending, did we have performances? No, it was performance. So what I'm going to do, for the sake of helping you, my dear students, and the rest of the learners be able to capture, once you have known the power of the names that you use in your program, then I can rename this folder to performances, or this file to performances. And note, it is in the folder for the program that we are running. And our program is this one. This is our program, file struct read display. So let me execute this program again and see whether it will allow us to proceed. So start without debugging. You can see that now the file has been found. It is there. So how many records do you want to read from the file to the structure? Let me type 3 and press enter. You can see what it is saying. The 3 students' records as read from the file into the structure are as follows. So what are we getting? We are getting no records, meaning we are reading something that is not already there. So what are we supposed to do? We should ensure that we are reading from the correct file. Now, my dear students and the rest of the learners, it is good to note something here. When you execute this program, after we have executed it, you have noticed that the way we are reading, sometimes the read write ahead may read, or the compiler may read an empty space in the file or the wrong data. So if you are reading data into a structure, it is important to ensure that the format of the data in the file that you are going to read from is per the structure. So like in our file here, if we go to our folder again, and then we check, if we open this folder or this file, if I open this file, for example, under file reading, if we open this file called performance, you realize that it has other text like this. So if we are to read this data into our structure, our struct as it is, then it is important that the data that we have is the data that can fit in the structure. Otherwise, we shall require to do some more resets. So what we need to do is, for example, to remove some of this extra information. And for example, have our file like that, where we have our data organized in formal structure. So when you are writing data into a file, it is important to note how you are going to read and where you are going to read it to display it. If you are going to read data and display it in a structure, then you must ensure that your format is right. So in this case, my performances will be as follows. It will be that way. So from there, once I've removed those headings, I can run my program again. Let me execute my program. Start without debugging. And then, how many records do you want to read from the structure? I'll type 4 and press enter. You can see that now I'm able to read my data. What about if I execute, for example, type 5? You can see that my data is now read and stored in the structure, is being read from the structure to the screen. So that's how this program is going to behave. That's how we read data and store it into a structure. So we can press edit key, continue, and then we go back to our program. Now, other than sequential files, we also have what we call random access files. Random access file enables you to read or write any data in your disk file without having to read or write every piece of data before it. You can quickly search for and retrieve, change, and delete information in a random access file. A record to a file is a collection of one or more values called fields that you read or write to disk. Generally, you can store data in structures and write the structure to data disk where they are called records. When you read a record from a disk, you generally read that record into the structure variable and process it with your program. When your program reads and writes files randomly, it treats the file like a big array. With arrays, you know that you can add, print, or remove values in any order. You do not have to start at the first array element sequentially, looking at the next one until you get the element you need. You can view your random access file in the same way, accessing the data in any order. Most random file records are fixed length records. Each record, usually a row in the file, takes the same amount of disk space. With fixed length records, your computer can better calculate where in the disk the desired record is located. With random access files, you can read or write records in any order. Therefore, even if you want to perform sequential reading or writing of the file, you can use random access processing and randomly read or write the file in sequential record number. To open a record or to open a random access file, you must open the file before you can read from it or write into it. You can use any of the read access modes that we have already discussed under the sequential access files to read a file randomly. However, to modify data in a file, you must open the file in one of the update modes. That is amp for append, add, in, out, binary, trunc, non-create, no replace. There is really no difference between the sequential file and random files in C++. The difference between the files is not physical, but it lies in the method that you use to access them and update them. For example, if you wanted to create a file of your friends' names, the following open function called services, assuming student pointer is declared as a file pointer, to be used to manipulate a file called names, and therefore you can code it as follows. So we have student pointer dot open, and then we have the name of the file as names.dat, and you can see the way we write the opening mode is similar to what we have discussed under the sequential files. And then you check if the file is existing and if it can open. If it does not exist or it can't open, you write a message for not found. But if it is found, you continue. So no update open function access mode is needed if you're only creating the file. However, if you want them to create the file, write the name to it and give the user a chance to change any of the names before closing the file, you can open that file as follows. Student pointer dot open, the name of the file, then input output stream, open for reading, and also open for writing. So you can open a file for reading and writing at the same time. And then, of course, you check if the file can open. If it cannot open or it does not exist, you display the error message, just as you have learned. Then under random access files, we have a special function that we call the seek function, which is a function that enables you to read to a specific point in a random access data file. Its format is normally as follows: file pointer.seek_g, then long num origin, and then we terminate it with a semicolon, whereby File pointer is the pointer to the file that you want to access, initialized with an open statement. Then long num is the number of bytes in the file you want to skip. If long num is negative, C++ skips back once in the file. This allows for retrieving of data several times. Because data files can be large, you must declare long num as long integer to hold a large amount of bytes. Origin, on the other hand, is a value that tells C++ where to begin the skipping of bytes specified by long num. Origin can be any of the following three values. It can be seq set, that is, when you want the reading to begin at the beginning of the file, and its equivalent is ios beg for beginning. Then we have seq car, which is specific for reading from the current file of possession. And then we also have seq end, which looks for the end of the file. The origin, seq set, seq car, and seq end are defined in the file special file that we call stdio.h or stdio, standard input-output file. The equivalence for seq set, seq car, and seq end is iosbeg, ioscar, iosend, as defined in fstream file. So if you are going to use seq set, seq car, and seq end in your program, you must have preprocessor directive for stdio. But if you're going to use iosbeg, ioscar, and iosend, you need to have the preprocessor directive fstream. The file pointer continuously points to the exact location of the next byte to read or write. As you read data from either sequential or random access file, the file pointer increments with each byte that is read. By using the seq_g function, you can move the file pointer forwards or backwards in the file. For example, no matter how far into the file you might have read, the following seq_g function positions the file pointer back to the beginning of the file. File pointer seq_g 0,0l seq_set, which positions file pointer at the beginning, that is 0 bytes. The constant OL or 0L that we have seen passes a long integer 0, the seq_g function. The seq_g function literally means move the file pointer 0 bytes from the beginning of the file. So the following is an example of a program that requests the user to enter the name of a file to be read from, which is then displayed on the screen and sent to the printer if available. If it uses 3 pointers, one for reading from the file, the other one is for writing to the screen, and the other one is writing to the printer. So here is our program. It reads the contents from a file entered by the user, then displayed on the screen and sent it to the printer if available. So we have our preprocessor directives there. As usual, we have the file pointer for inputting data from the file. We have for writing to the screen and for writing to the printer. For reading from the file to the program, we have what we are calling in file. So we use if stream. But for writing out, we have off stream, scrn for the screen, and prnt for the printer. Then we have our main function there. We have a variable car, and we have the array of car, which is supposed to hold the name of the file that we are going to be reading or want to read from. Then we have the statement. What is the name of the file you want to display at the print? You type the name that you want for exam performance. Once that is done, the name of the file that you have entered will then be opened using the file pointer in file in the reading mode. And then you check if it exists. If it does not exist, then the message will be displayed. The file does not exist, or you have not added this extension. Kindly retry and then end the program. Otherwise, send or otherwise open the screen, then they receive output. Then do the following. Do the following. While the file contains content, read that content of the file until it is completed, until you complete reading. So read all the content from the file, and as you read each of the characters, write it to the screen. So read from the file a character, write it to the screen. Continue until there are no more characters to be read. Then close the screen once you are done. Next is to open or to reposition the pointer. In other words, take the read write ahead to the beginning of the file, and then send the content of that file or open the printer, ready to receive the output. And then do what? As long as the file contains content, continue reading each of the content in the file one character at a time as you print it on the printer or as you send it to the printer until there are no more characters in the file to be sent to the printer. Then close the printer. Then also close the file that you are reading from. Return the control back to the main program or back to the caller and end the program. So let us code this program in C++. We compile it, we execute it, and then we see how it is going to behave. So let's proceed. As usual, we close this program. Let's close the solution. And then we start our new project. What is the name of our program? The name of our program is file random access. So we click on file, new project with data2. We call it file random access. Remember, if you're using other versions of C++, you don't need to follow the long procedure that we follow when you are writing source code in or using Visual Studio 2010. So the name of my file is file random access. Then we are just going to copy our program. We shall copy our program. Here is our program, file random access program. So we're just going to copy that program just as it is, paste it on our editor, save it, then compile it. Good. Our compilation has been successful. Then we can run it. Let's see. What is the name of the file you want to display and print? Let me write performance. It does not exist. Let me run again. It is performance.txt. It does not exist. Why? I've already said that the file you want to open, you must give it a complete path name, or you have it in your folder where the program you're executing is. So let me copy these two files. I hand this file and add others. So let me go to the folder called file read struct display. I open this file here. So let me copy this file, copy that file, and paste it in the current folder for the program I'm running now. That is file random access. So I'll copy and paste my file here. Let me also go and open another one. I want to copy. There was also another file here. There was a file here, which we call the performances. I want to close that. Let me open another one. Let me open this one, or copy this one and this one. I want to have several of them into my folder, file random access. Let me paste them here. So I have several now. So let's go back to our program and run them, execute. So start without debugging. What is the name of the file you want to display at the print? Let me write now, performance.txt, and the print. Press enter. You can see that the file called the performance has been read and the content has now been displayed on the screen. And of course, it has also been sent to the printer, but my computer is currently not connected to any printer, and therefore there has been no printout. If the printer was in place, this data which is displayed on the screen would be generated or printed out. Let me read another one. Let me execute and enter another one. Let me type the one, the file called results.txt. Press enter. You can also see there is some data in that file. So that data has been read randomly and is displayed on the screen. What about if I type another one? I want to print or I display another one. Let me call it performances.txt. What is there? You can see the content is different. So my dear students and the rest of the learners, that's how you can be able to open content. You can open content of a file randomly and print it, display it on the screen and print it in the order of your choice. In the order of your choice. And with that, my dear students and the rest of the learners, we have come to the end of part 13 of the 13-part series of tutorials or presentations in C++ computer programming. Just as a reminder, kindly go through part 1 of 13 to part 13 of 13 in this series so that you can then claim to have the mastery of programming using C++ programming language. After this series, once you're done with this 13-part series, I would also advise that you go through the 95-part series of tutorials in object-oriented programming using C++ so that you can then be able to know how you can advance from this level to the next level in C++ computer programming. Congratulations, therefore, for learning part 13 in C++ computer programming series by the title Files. You can access the rest of the parts in the series, as well as other computer or ICT videos by clicking or tapping on Emily Swap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emilyswap@gmail.com. Thank you for having been part of this journey of learning C++ programming from part 1 to 13, and I wish you all the best as you graduate in C++ computer programming, and God bless.